This is UMLs03. So now we're on to lesson 26, I think, of our Python curriculum. Okay. And so basically what we've been talking about is intermediate functional programming. So now we're starting to use functions to complete more interesting tasks. And now that we have an understanding of lists and tuples and sets and dictionaries, we can basically start to apply a particular function, whether it's a regular function or a Lambda function, to multiple elements in a particular list. Okay, and then we said that we can also filter a list according to whether or not every element in the list, each element in the list satisfies a particular Boolean. And we said that we can use a filter, so filter of predicate with iterable. So let's go ahead and review that. And then in this video, we're going to be talking about a slightly new topic. We're going to be talking about something called generators, okay? And we've actually seen generators before. We've seen 4 or 5 pretty important examples of them. And so we're going to understand what they mean conceptually and how we can build up our own generators, okay? So we know that functions can be inputs to other functions, right? So we've already seen this several times, right? So we have define main function. So main function accepts 4 inputs. But if you look in the context of the way this function is written, it seems like do something, that first input would have to be in and of itself a function, okay? Because it has basically these parentheses, and it seems like it's taking in the other inputs as parameters to that function, okay? And so then what that allows us to do is if we say main func of sum them, right, we just feed in a function name, no other parentheses or anything, but with 4 numerical inputs, then indeed we could get that result. So we've seen that in action before. Hopefully you're convinced with that and you're confident with it. We also talked about a Lambda function, and we said basically we already know how to define a function. So we define function name of variable name, so any variables that you're going to return into the function, right, that you're going to accept into the function, and then return, and then some function, right? So then if you say, if you define f of x and y, then you could say return x plus y. Okay, how would that work in the Lambda case? What you would do is you would, instead of saying define f of x plus y, or f of xy, return x plus y, all you would do is you would say basically f equals lambda x comma y colon x plus y. So hopefully this would be an easier way to do it. So you could say lambda xy, and then you would just have the rule for it. So x plus y, this would be equivalent to define f of xy, return x plus y. So hopefully you're comfortable going back and forth between a lambda interpretation and a regular interpretation. And you have to remember that lambda functions only apply to functions that return values, okay? So for functions that just print something, it doesn't make a lot of sense to talk about a lambda function, okay? So what we're going to do, remember we also talked about map of function iterable. Okay, so it's just like enumerative v or range of 4 or dictionary.keys. And more generally, these types of functions are actually going to be the subject of this lesson. But anyway, what we did is we said that it can be iterated through using a for loop, right? You can, like we said, you can say for y in range of 4 or for w in map of function iterable, okay? But if you want a list or tuple, you would need to convert it to that, okay? So the only thing you can do with it is iterate through the elements of the map, and you would need to do it with a for loop, okay? You'd have to keep it very simplistic. For w in map of function iterable, and then you could say print of w, okay? And so that would print the value of the function applied to each element in the iterable. So if this is like f of x is x squared plus 2, right? And then you have a couple values in the list like 5, 6, 7, well, then it will go ahead and do, 5 squared plus 2, 6 squared plus 2, and 7 squared plus 2. And so then if you go ahead and do, for u and map of function iterable, that's what will be printed just one at a time. And then it also works with lambda functions. So we saw this already. This is the exact same example from previously. So if you said add 5 equals lambda c, c plus 5. Okay, so this is the rule. So what does add 5 do? What does add 5 do? It accepts a c and it returns 5 bigger than c. Okay, so for u equals 3, 23, 43, that list, if we said for a and map of add 5 and u, we could say print of a. And so if we say print of tuple of map of add 5 and u, we would get 8, 28, 48. But if you just said print of map of add 5 and u, it would just basically say, oh, that's a mapping object or something like that, right? That's not very interesting if you said that. And we saw an example of that, but you'd have to convert it to a list or tuple if you actually want to see a list or tuple. Otherwise, if you don't want to convert it to a list or tuple, use a for loop and just iterate through it arbitrarily calling each element. So hopefully that makes sense. And then we have filter of predicate and iterable, okay? It's another type of thing. It's like range of for, map of function iterable, right? You can't just say print of filter of predicate and iterable, but you can say for W in filter of predicate iterable. So we can iterate through it, but it's not a list or tuple until we convert it to one. Would iterate through all the elements in the iterable that satisfy the predicate. Okay, so what we said it as a predicate is equal to, for example, lambda W, and then basically some Boolean, so some function of W, like W greater than 0, or W plus 2 equals 0. Or if you're talking about a string, length of W not equal to 4, right? But a true or false statement, okay? And that would just apply arbitrarily to each of the elements in the list, okay? And so then you would just go ahead. So then if you have a list here, and then if you say for A in filter of lambda S, not S mod 2 equals 0, and then comma group. So you need to pass in a predicate, which is basically just a Boolean. And then you need to pass in a list, like an iterable, like a list or something, okay? And then you would say print of A, okay? And then that would print all values in this list such that A is odd. So hopefully that makes sense. And we saw a pretty similar example in the previous video where we just wanted to print the negative values in a list, and we did that at the very end. A generator is a function that returns an iterable that is non-indexable and must be referenced either in a for loop or converted to a list or tuple or set. So if that kind of characterization sounds sort of familiar to you, that's because we've already seen examples of generators, okay? So remember, we said that basically we could say for W in range of 5, we could say print of W, okay? And that would print 0, 1, 2, 3, 4. But then if we just said print range of 5, it had a hard time printing 0 through 4, right? It just literally printed range of 0, 5 on the output. And that's not very helpful, right? So then, same thing, print of enumerate of 2, or print of map of function iterable. And we said that you need to convert those kinds of things to a list or tuple unless the only thing that you're going to do is for W in that thing, print of W, okay? So, but if you want the list or tuple, you got to convert it. So these functions basically generate values that can be referenced directly in a for loop, but they're not formal data structures. They do not return values, they yield values, okay? So basically what it means is that yielded values can be mentioned directly by use in a for loop, but they cannot be referenced directly, okay? So basically I said the same thing twice here, but these are the things that we're gonna talk about. So I think it's helpful to go ahead and remind ourselves of how doc strings work. We've talked about it 2 or 3 times pretty briefly in the past, but I just want to remind you that it's really important to have formal documentation underneath each function header, okay? So our functions have been pretty simple, right? Like f of x is x times 2. But if you go, into the software engineering world, your functions are going to get a little bit more complicated than adding 2 to an input. And so you're going to want to have documentation of what the function does, right? And so we have the 3 pairs of double quotations. We've seen this before. It's like a multiple line comment, kind of, but it has a special purpose in Python. Usually we use it for formal documentation. So you're going to have a quick little description, accepts 2 function inputs, and 1 value-based input x, and prints the sum of the first function applied to the second input x, and the second function applied to the input x, right? And it tells you basically very descriptive parameters. And this function doesn't return anything, so you don't need to have a return section, but you would just say print of f of x plus g of x, right? And then you could say first function of t, so this function accepts an input t and returns the result of 2 minus t, parameter t, return 2 minus t. So this is a very simple doc string, and hopefully you're getting comfortable writing these on your own. Return 2 minus t. All right, second function of t would be t mod 2. So the result when the remainder when t is divided by 2, and it explains how that works, right? And then you could also have a third function. So you could actually define a lambda function inside of a normal function, right? So what if you said define third function of t, right? And so what does t do? Well, what we're going to do is we're going to come up with a lambda function that's defined by x plus 10. And then we're going to evaluate that lambda function with the input t. So really all these 2 lines is just sort of a fancy and fun and slightly confusing way to just say return t plus 10. So hopefully that makes sense to you. And then we also said that we can have, so then if you go, what if you have f1 equals lambda dog, right? You accept dog, and then it would just return dog and then concatenated with woof, right? And so this would basically be a function that acts on a string. And then same thing with f2, right? And so what if you say print of f1 of the dog said and f2 of the dog said of the cat said, right? So it's going to say the dog said woof and the cat said meow. So now if we go ahead and run it, that's the first thing that's printed on the console. What if we go ahead and have a function with multiple inputs? So remember lambda functions, okay? Lambda functions can accept multiple inputs separated by commas, and they don't have to use all those inputs. So technically this function accepts 4 inputs, but it really only ends up depending on 2 of them, right? A and D. So you can say F3 of 5, 2, 1, 100, and it'll do 5 minus 100 to get negative 95. And you have a different set of inputs here, but the same output because the function only depends on A and D, which were the same between these 2 function calls. And then now we can think about the map, right? So then we have values here. We just have positive integers. And then we have a lambda function where we accept an input and add 20 to it. So if you say for R and map of 20 larger and values, you could say print of R. Okay, it's called a generator. So we're going to be seeing that. And then you could say print, yep, just applied 20 larger to the next value in the list. And you keep seeing that iterated over and over again. 28, yep, just applied. 23, yep, just applied. 25, just applied. And that lines up with the elements here. Being inputs to the 20 larger function. So what yieldFives is going to do, we have a function here and we have a little doc string for it. This function accepts a positive integer x and generates that many fives. If x is not an integer, then the number of fives printed is the int form of x. Okay, so we're going to accept a positive number. That's not too hard. It can be negative, but that wouldn't really, it wouldn't yield anything. It wouldn't be very interesting, but technically it could be. And it generates 5. So let's think about a new keyword in Python. We're going to think about this word called yield, which you see on line 152. What this does is we're going to have an input x, right? And we're going to say counter is equal to 0. And then we have while true. And we remember from our study of while loops is that the while loop keeps iterating as long as this main Boolean is true, unless there's a break out of it. So the only way that we're going to stop this loop is if counter becomes greater than or equal to x. So counter starts out as 0, right? And 0 is not bigger than or equal to x, right? By presumption, we're passing in a positive number. So let's say you say yieldFives of 4, okay? And so that basically we're going to pass in x equals 4, right? And then so 0 is not greater than or equal to 4, so we're going to yield a 5 and we're going to increment the counter, okay? So we just yielded a 5, whatever that means. And then counter goes up to 1, okay? And then obviously true is still true. The question is we still have to check this Boolean. So is 1 still greater than or equal to 4, the input that we passed in? Is 1 greater than or equal to 4? No, it's not. It's still not true. So you come down here and you yield another 5. And so basically you can see according to while loop architecture, this yields 5 x many times, right? And then hopefully that's clear enough to you logically what's happening with that. So what we're going to try to do is we're going to figure out what this yielding thing is doing, right? If we say print yieldFives of 3, are we going to see 5, 5, 5? Are we just going to see 3 5s each on, you know, one on each line? So let's go ahead and scroll down, right? We were iterating this just applied 20 larger thing, and I wanted to show you how that worked. But then if you go ahead and print yieldFives of 3, this is the console output that corresponds to that. So it says generatorobject yieldFives, and then it has some kind of a memory address or a hash code representation or something like that. And that's not very helpful. And that might remind you of basically what happens if we say print of range of 10, right? And so this is an example of something that we've seen before. This is called a generator, okay? And so it doesn't really know how to print that. So it just says range of 0, 10. And so what you need to do if you want to basically get a result out of here is you have 2 options. So for a generator, okay, to work with a generator which yields rather than returns numbers, you know, either use a for loop and, you know, and say, you know, for, you know, w in, and then you could say yieldFives of 3, right? You know, or convert the result of the function, of the generating function, to a list, tuple, or set. Okay, so if you say print yieldFives of 3, we saw the problem with that. But what if we say print list of yieldFives of 3? So that's why you see this list here, right? We got those 3 5s. It yielded 5 3 times, okay? Because for x equals 3, this else Boolean, you know, this Boolean fails 3 times, right? For when counter equals 0, counter equals 1, and counter equals 2. Those are the 3 values of counter for which this Boolean is not true. So we don't break out yet, and we yield 3 5s, and those show up in a list. They could also show up in a tuple. You know, that's why you see a tuple here. And then they could also show up in a set. And why do you only see one element? Because we said that sets cannot have duplicate elements. So if you're yielding the same thing every time, your set is going to have only one element in it. Okay, this is how you use a generator. Basically, this is the common use of a generator. So we say for w and yieldFives of 3. And we've seen more general examples of this, right? We don't say you don't say print range of 4. You say for w in range of 4. Okay, and so then you could say print of W, and it would go ahead and print those 3 5s that were yielded, right? This would be the same thing as if, remember, you can always just keep it safe, and you can always convert a generator to an actual list. You could say for W in list of yieldFives of 3, okay? And then you could go ahead and print those W's. Now you get 6 5s, right? 3 from here and 3 from here. Let's think about another generator, so generateTwoOfEach. This function accepts a numerical input x, presumed positive, and generates 2 times each value, for, from 0 up to x minus 1. So remember how range of x sort of generates up everything up to x minus 1, right? 0, 1, 2, 3, 4. It's yielding those values, okay? So if you wanted a definition of range of x, basically it would say y equals 0, while y is less than x, yield y, and y plus equals 1. This is the definition of range of x. This is what range of x does. Okay, and I don't know if it's written exactly like that, but that is the implementation of it, and that's equivalent. So then what you would do is you would have generate 2. So you're just actually going to yield y and then yield y. So for example, remember, let's pass in x equals 3. So we're going to say y equals 0. While true, okay, so this loop is going to run forever unless y becomes greater than or equal to x, because that's the only way that the loop terminates. So then for x equals like 3 or 4, if we start at y equals 0, you can see we're going to yield each value of y, and then y is going to go up every time. So eventually this Boolean is going to become true. For any positive value of x, y is eventually going to work its way up to it. Okay, and so you say yield y, and then go to the next value of y. Okay, and then yield y, and go to the next value of y. So what we're going to do is we're going to say t equals generateTwoOfEach of 4. Okay, so it's setting the output of this function, this generator, equal to t. So now what happens if we just try to print t? What if we just want to print the result of generateTwoOfEach of 4? So we get the generator object, right? And it says this generator object, and that's not very helpful. So print of t is that's not very awesome, right? But if you say print of tuple of t, then it would go ahead, you can see those yields, right? So it yielded 2 zeros, and then 2 1s, and then 2 2s, and then 2 3s. Why do we not get any 4s? Because we said that by the time you even get greater than or equal to x, right? Not greater than, right? So once y becomes 4, you cannot yield those 4s because you're going to break out before you even have the opportunity to do that. Okay, what if you said, let's go ahead and say something else, right? So what if you had said something like for s and t, what if you had said something like print of s? Okay, so now we can go ahead and run this code. Okay, so basically we have an issue if we just say print of t, right? And then we try printing that generator object, right? We could get the 0 0 1 1 2 2 3 3 here, but what I've done a slight modification. So I went ahead and removed print of tuple of t, and now I just say for s and t, right, in the generator, print of s, and then it's able to print out those 8 values. But you can see the difference, right? You can see the difference between a generator, which doesn't return a list or tuple. It simply allows you to iterate through the elements in a for loop. That's the only thing you can do unless you convert it to a list or tuple. We're running out of time, but in the next video, I'm going to want to talk about this reverse enumerate. So we're going to see one more example of a generator. So the way that you denote a generator is with this yield here. So let's think about what this does. So with the reverse enumerate function, it's going to accept a list. Okay, so this function accepts a list, and it's going to generate a tuple for each element in the list. And so we can think about the enumerate generator. Remember 1 or 2 lessons ago, we said basically the enumerate of V. Okay, so enumerate is a generator and accepts a list. And what it does is it generates or it yields tuples. And we said basically the tuples, there's 1 tuple for each of the elements in the list. Okay, how long is each of those tuples? It's 2 elements. What's the first element? It's the index position for that list element. What's the second element in the tuple? It's that element. It's that list element, right? And we saw examples of basically pairing each index position with the element that was at that index position. But what if we wanted to go ahead and generate tuples where we actually went ahead and gave the person the element in the first index position of each tuple and the index position in the second index position of each tuple, right? So basically, remember that the way that with the generator, what we do is we get these tuples, right? And so with enumerate of V, we get these tuples, right? So you get 0 and then whatever's at index position 0, and then 1 and then whatever's at index position 1, and then 2 and then whatever's at index position 2. So in the next video, we're going to get some more practice with generators, but we're going to want to generate tuples that get the element at index position 0 and then 0. and then another tuple with the element at index position 1, and then 1. So we're basically going to invert the order of those, and we're going to get some more practice, but I'll explain that more in the next video. I think that's enough for now. So from me, Mills03, thanks for watching, and please subscribe.